next, I want to do an example for you. And the situation here is that you have a person sitting on a cushion, and we want to just ask, what is the distance from the ground to the top of the head of this person? So this isn't that hard of a problem, but I want to talk you through the process. So the first thing to note is that you have two distances. One is 0.8 meters, the other is 15 centimeters. Now note that just looking at this, you can see that we need to add them together. So if we're going to add them together, we need to actually do a unit conversion. Why? Because they're in two different units. If you just added 0.8 to 15 and said, oh, it's 15.8, well, what, 15.8 meters, 15.8 centimeters? It doesn't make sense to add two different units together. So now the choice would be yours as to whether you want to have both numbers in meters or both numbers in centimeters. Now, for this problem, I'm actually going to convert it to be centimeters. And while this might be something that you could do pretty easy, I'm going to do it out explicitly. So if I have 0.8 meters and I want to convert it to centimeters, I'm going to multiply it by a number that is equal to 1. And on the bottom, I need meters, and on the top, I need centimeters. Now, I need some number that expresses the equivalence between these, and it's true that 100 centimeters equals 1 meter. So now note that my meters cancel with meters, leaving centimeters, and so 0.8 times 100 is 80. Now, one thing to be careful about here is that this was actually only one significant figure. So if I've written it as 80 centimeters, that somewhat implies that there's two sig figs here, so you might want to remember that this is only really one sig fig. And that could be one reason why it could almost be better in this situation to convert centimeters to meters. So now you have 80 centimeters plus 15 centimeters. That's easy to add together, and I get 95 centimeters. Now, there's one more thing you want to do, though, and that's actually remembering your sig figs. If you don't know what I mean, there's a separate video that goes through sig figs in more detail. Now, in this case, I only want to have one significant figure, and that means I need to round. So since this is a 5, that means I need to round up. That's actually going to make this 100 centimeters. Now, one thing that you could do here is note that that could look like it's actually 3 sig figs, like maybe those zeros count. So you could write this as 1 times 10 to the 2 centimeters, and now it's very clear that you only have one sig fig. Now, if you actually did your conversion a different way, and you had 0.95 meters, again, you would need to make that one sig fig, and this would become 1 meter. And what you hopefully see is that 1 times 10 to the 2 centimeters is also equivalent to 1 meter. So we're not done yet. The next thing you have to do is ask yourself, is that reasonable? And this is where, if you don't have much of a feeling for centimeters or meters, it might be fairly challenging to do this. But I know that 1 meter is about 3 feet. A different way to think about this is that people are about 2 meters tall. And if a person is sitting down, you expect that to be about half of their height. So this isn't a very exact check, but if you had gotten 15.8 meters, that's huge. That's way taller than a person. So I would have known that that was wrong. Similarly, had you gotten 15.8 centimeters, that's only a couple of inches. Again, not the length of a typical person's torso. So really looking at what your answer is and asking, does it make sense, is really important to do. In this case, we did this unit conversion, and we also were careful about our sig figs and rounding. So for more examples of doing conversions and using these other tools, do see the problem-solving videos and the tutorials on Moodle, on Mastering Physics, excuse me.